A pseudo NMOS inverter. A figure shows a pseudo NMOS inverter for which the W by L of the drive transistor is 1/2 of the W by L of the load device, that is W by L 1 is equals to W by L 2 by 2. Here you can see the figure, a typical pseudo NMOS inverter in a 0.6 new meter technology. This would be a typical choice for a pseudo NMOS inverter having a p-channel load with a 1.65 volts gate bias voltage. A simple circuit capable of realizing this bias voltage will be described shortly. In this session we will analyze the pseudo NMOS inverter for its approximate gate threshold voltage gain at threshold, typical output high and low voltages, and approximate transient response. To make this analysis tractable, a number of approximations will be made. The errors arising from these approximations vary somewhat, but in all cases are typically less than the errors caused by the inability to accurately predict the processing and transistor parameters prior to manufacture. Also, by making reasonable approximations, the essential operation of the gate becomes more obvious without mirroring the reader in the calculation that are of limited use in designing practical digital integrated circuits. Irrespective of the use of approximations in this session relies heavily on the understanding and the equations that describe MOS transistors, which were presented in chapter 3. Thus, not only this session gave greater insight into pseudo and MOS logic, but it will also serve as the first in-depth example of the application of MOS equations to actual circuits. Thank you.